7. This is 5-7, and we are doing graphing a system. I asked everybody to stand up if you are 13. Now, please stand up if you are born in January. Okay? If you're 13, sit down. If you're born in January, stand up. Okay? Okay, so stand up if you are 13 and born in January. So, oh, darn. We have no solution to this system. Let's try it again. Stand up if you are born in July. Okay, let's try it again. Stand up if you are born. Shh. Stand up if you are born in October. Shh. Stand up if you are 13. Sit down. Stand up if you are 13. Anybody 13? Now, stand up if you are 13 and born in October. I should have picked October. Okay, so for those of you that are standing, you are the solution to this system. The system is the solution is the intersection of both categories. Although it says January, we're really talking October. So we would say that Jack and Julian are the solution to the system of inequalities. Okay, so that's just like a real life situation. As mentioned before, we are graphing systems of linear inequalities. We will not have a lot of time to go through a lot of these, so please make sure you're taking notes as we go. So when you have a system of inequalities, we're basically doing the same thing we did yesterday, only we're graphing each inequality one at a time. So I'm going to start with y is less than 2x plus 3. So I am starting, and what's the first thing we always do when graphing, especially with an equation and slope-intercept, Chris? We identify. Everybody say identify. The slope and the y-intercept. So what is my slope, please, Chris?
2.
M equals? 2. Please say it completely. And my y-intercept?
Equals 3.
Perfect. So my starting point is where? When I go to graph, Leora?
3 on the y.
Axis. Good. 3 on the y-axis. So I'm starting at 3, and now I'm going to rise 2, run 1. Rise 2. I can't go any further up, so I'm going to go negative 2. That means down, and left negative 1. Negative over negative makes a positive. Platy. Oh, you weren't here yesterday. So, do you know if this line will be solid or dashed?
Solid.
It will be solid because it is equal to. Good. Okay, so we know that we're going to make a solid line. Now, in terms of the shading, the question that I always do is, what I do is I kind of get rid of this and really use my y-intercept. So when they say y is less than or equal to 3, I look at my y-axis, and this is a number line, Platy. Here's 1, here's 2, here's 3, here's 4, here's 5. And so when notice I've crossed this out, it says y is less than or equal to 3. Where are the numbers in relation to this point? Where are the numbers less than 3, Platy? Above or below that? Below on the y-axis, they are less than 3. So that is the area of shading that I will do. So I will do my area of shading. Now you can do your shading in a couple different ways. You can shade it in neatly, or you can use directionality. Like if you only have one color, you can use lines. So I might do something like this. For this line, everything shaded in this area, it's going to be up and down. Okay? Now, the next equation, let me do that in red, and I'll show you directionality. this becomes very difficult to read. And that's why I'm telling you how to make it clear for me. I have 200 of you, and let me tell you, it is like trying to get through all that scribble is very difficult. Some kids, I'm like going, where is their solution? Okay, now I'm going to do the other one. Let's use black. 2y is greater than x minus 2. So what would I do first? Here, slow.
You would divide by 2.
Divide all terms by 2. And I get y is greater than 1/2 x minus 1. Next step, please, Nicole.
Then you would identify the slope and y-intercept, which is half, where the slope is half, and for the y-intercept it's -1.
Good. And so I go back to my original origin, and I go down to -1 on the y-axis. And now I'm going to rise 1, run 1, 2. Rise 1, run 1, 2. Rise -1, 1, 1, 2. -1, run 1. Okay, and then I'm going to draw myself a line. Now, is this line going to be, solid or dashed? I just heard somebody say dashed. So I just kind of come over here and I erase my way. Okay. Now, so it's dashed. Am I going to shade up or down? Now remember, I temporarily block this out, and I read this. Y is greater than -1. Where are the numbers greater than -1 on this y-axis? Above or below that dash? What'd you say? Above. So now look what I'm going to do. If I only had one color, above the whole line, I'm going to go horizontally. Now, the solution is only where the plaid part is, where you have the crossing of both lines. Do you see that in that middle there? A good idea would be to draw an arrow and say solution. Don't draw an arrow and say double shading. I know it's double shading. I want to know if you know what the solution to this system is. So if this were a real word problem, Jack, this double shaded area is the area where Jack and Julian, right, and every other kid that's 13 years old and born in October, you guys are all in here. Does that make sense? Yes.
So, is it okay if we circle where the solution is, with a different color?
I just have to be able to see the boundaries. So be careful when you're circling. I prefer you to put an arrow and say solution. Okay? Now, yes.
On the test, would we be able to use different colors?
Yeah. I've got pencils back there. So if I'm doing it without, you will notice, if I'm doing without it, I would use different colors or different directions. One of the two. Don't use the same color. I have some people that copy light, and then do dark. They just copy my picture, and then they can't redo it. They can't do it again on their own if you're just copying this. Remember, shade for each line, then move on. Don't draw the picture afterwards. Does that make sense? Okay. Questions here? All right. You can pause the recording and try the next one on your own. Yes?
So when there's no solution, there won't be
There'll be no inner overlap. So again, a solution to a system. Now, one kid said to me, do I circle this and label the intersection? Would I?
No.
Why?
the line's not really actually there because one of them is dashed.
No.
There's multiple, and also that line is not actually there. So that
What solution is that? What is that a solution to, Daniel?
that's the solution to a system of linear equations.
Equations, not inequalities. This is the solution to the system of equations, not the system of inequalities. Here is the solution to the system of inequalities. Okay? I should put solution, not system. Okay, questions. So I kind of prefer you not to circle it. I don't like that because then I can't see the boundaries. Do you understand? All right, so you can pause it and try this next one on your own. But in terms of the class, we're going to move on a little bit and just talk about certain things. Because I want to make sure I get through the video. If we don't get through the video, if we get through the video, then we can practice more. So again, you're always identifying your M and your B. And check your work. Okay, what kind of line is this when it says y is greater than 3? Let's go with Daryush.
Horizontal.
It's a horizontal line. But to be safe, I want you to create a table. The work is a table. Have I not said this from the beginning? Okay, and when I do my table, y is greater than 3. Make your table. Here's your x. Here's your y. Pick 2 points. What 2 points am I picking? What must be when you have y is greater than 3? Andranik.
X needs to be, y is 3.
Always 3. And I choose my x's. Then that makes it, I plot those points. 0, 1, 2, 3. 0 across, 3 up. Sorry, 1, 2, 3. 1 across. And we can see the directionality of the line. Is that solid or dashed? Dashed. Now, the other thing, if you want to identify the M and the B, I would accept that too. But I want one method of work. Either a table or identify your M and your B. Personally, I think when you put it in the table and then you plot those points, it keeps it straight in your head. I get a lot of kids confusing what's a vertical line and what's a horizontal line. So when they're single variable, if you make the table and then plot those points, if something's constant, put it under that letter. Does that make sense? Are we shading up or down? Up. And then we're going to take the other one. We identify our M and our B. Solid or dashed? Dashed. And then we are going to shade which direction? Down from that y-intercept, so that's down below, anywhere underneath that line. Not just underneath here. So my solution is only in here. Are there any questions? Okay, let's move on to a couple other things. If it's in standard form, please put it into slope-intercept. That means get your y alone. Identify your M and your B. Question?
Is 5.7 going to be on the quiz?
Yeah. Okay? So remember, put it into slope-intercept. Are there any questions there? Okay? Don't forget, what's the big problem that people will encounter here? Nicole, I'm asking you for a reason. What's the big problem people will encounter?
The y-intercept is... it says you have to divide by a negative, so you have to switch the sign.
Right, and this is where I have a lot of people forgetting. You're nervous, and you're nervous, you're shaking, you're forgetting to flip the inequality sign. Julian? Okay, questions. So make sure to do that. All right. If there are 3, don't get worried. Just do each line individually. And the area of overlap is your solution. So we've got a horizontal line here. I'm going to go to 0, 0, -2. Okay, and how about 1, -2? And we are shading up. The next one is going to be a vertical line going through number 3 on the x-axis. Which way am I shading? To the left. And then we've got our third one. We've got to get the y alone. Subtract x. What do I do next, Nicole?
Divide by -1 again.
And
Switch the sign.
flip the inequality. And now I've got my M and my B, and I plot that line. And my shade, is it solid or is it dashed? Is it shading up or down? Go to your y slope intercept. It's shading down. Who said up? Do you understand why? Okay. Are you sure?
Yeah.
And so my solution to the system is here. Not this area where there's 2 colors, but it has to be all 3. If there's nothing where all 3 overlap, there's no solution to the system of 3 inequalities. Do you understand? It has to overlap for all 3. Are there questions? All right, let's try, now let's try writing the inequalities. We are trying to write the inequalities. So, since these are vertical lines, I want you to make yourself a little XY table. Give yourself, we're working backwards. You're going to pick 2 points. Any 2 points on this line, I'm going to choose this one and this one. What are those 2 points, Saffron?
-3, 0, and -3, 2.
Good. And so what equation would that be? Saffron? If you see a constant there, that's your clue. Want to pick a third point? What is that?
-3, 5.
Good. If I pick this, -3, 1. Okay, so what is x equal to? Always. When you see the constant, you put it like an x equals that. Now we have to change this to an inequality. Okay? Where does it get bigger? I mean, where does it get bigger or smaller? Are the numbers getting bigger or smaller? So if this is -1, -2, -3, -4, the area of shading, does it get bigger than -3 or smaller, Saffron?
Bigger.
So it's going to be greater than. Would it be equal to or just greater than?
Just greater than.
Because it's dashed. Do you understand? All right, let's make another one for the other vertical line. I'm going back to Saffron. So Saffron, I'm going to pick 2 points.
That's 2, 0, and 2, -1.
So what is the equation?
X equals 2.
Perfect. Except we're going to switch that out. And what symbol would I put in?
Less than or equal to.
Less than or equal to. And here is your system of equations. Do you understand how to write it? Thumbs up. Yes, I understand. Thumbs down, I don't. Zoning out is not an option, Jack. Okay. Jairus? Anybody having problems that I'm missing? Tony? Are you understanding? Okay, let's try one more. Okay, so let's start with the solid line. What do we have to identify, Leora?
The y intercept.
And the?
X intercept.
No, I don't need an x and a y intercept. The slope. Okay? So what am I finding? What variable am I using? I'm on this one right here. What's your y-intercept? You told me that. Okay, what variable do I use? No. That's part of an ordered pair. A y-intercept uses what variable, please? Yes. It doesn't matter. Anybody.
B.
What?
B.
B. B is your y-intercept. It is 1. What else do you need, Leora? When I ask you to identify, it's always the same thing, 2 things. Yep. And that is an M. And you should be saying to me, it should be so automatic to you. The M and the B. Now, I take my 2 points and I rise over run it. What is my slope? What's my rise? 2 over 1. So now you can build the equation. What is it? Y equals? Good. Now we're going to switch it for an inequality. I'm looking at, now here's what you got to be careful of. Y, 2x plus 1. Here's what you have to be careful of. This shading continues here. Right? Are you with me? So on my y-intercept here, are the areas that are shaded, that are touching the y-intercept, would it be above 1 or below? The numbers that it's shading, if the shading continued, it would eventually touch the numbers on the y-axis that are above or below.
Y is less than or equals to 2x plus 1.
Why is it less than? Let's look at these.
Like more than.
Here's 1. Here's 2. Here's 3. If I continued that shading, it would hit numbers on the y-axis that are greater than. So that would have to be a greater than or equal to. Is that making sense? Nicole?
But why does it continue shading up and not down?
Well, on the other direction it is. But I'm following this line right here. I have to stay on this line. Do you understand, Nicole? That's for that line. For this line, it starts here, and I'm going to continue it. You with me? So on the other equation, again, what's my M and what's my B? What kind of 1? So we know it's going to be Y is negative X minus 2. Now, look at the y-axis for this line with yellow. The only time it touches the y-axis is here, and here, and here. Stop. Are those numbers greater or less than? And it's not equal to, so here is your inequality. All right. Pause the record. Okay, so basically here's your inequality. I'm going to move on to a quick word problem before you go. And, okay, so let's look at, just remember, identify your M and your B, and then continue the shading. All right, I'll go past this. If you want to try this one, you can pause the recording and then check your work. Remember to get your y's alone. If you divide by a negative, flip it. Here's another one. You can try practicing writing the solutions to, writing the linear, Writing the system of linear inequalities. All right, so here's a typical word problem. You have at most 8 hours to spend at the mall and at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents the situation. How much time can you spend at each location? So step 1, we have to identify our unknowns. Let's say that X is the mall and Y is the beach, our two unknowns. Now basically what we're talking about is mall time plus beach time should be less than 8 hours. So we're going to write that. Mall time plus beach time is less than 8 hours. Next, they give us restrictions that our restrictions are that we want to have at least 2 hours at the mall. So that's just X, has to be greater than or equal to. At least means it could be 2, it could be 3, it could be 4, so greater than or equal to. And then we want and spend at least 2 hours at the mall and more than 5 hours. So that's also going to be Y is greater than 4. And now we just basically graph all 3 equations on one graph. Here's your Y equals. Only it's dashed. You've got your X plus Y is this oblique line. And then you've got your X equals, which is this line. Now, the solution to this system is basically that shaded area. So any combination of that would satisfy the system. Any combination of all 3, if you pick a number that's greater than 4, Y can be greater than 4, X is less than or equal to 2, and so we can pick any point in there. One particular ordered pair in the region would be 2.5 at 5. One ordered pair would be 2.5, so I go to, if this is 2.5, it'd be right there, and then move up to 5. This would be just one solution. I could spend 2.5 hours at the mall and then 5 hours at the beach. So again, there's no one answer to this because that whole shaded area has a multitude of situations. And that's the end of the lesson.